Earlier this year, Tesla became the fifth firm to surpass the $1 trillion mark in market value. The market cap of Tesla has increased by more than $500 billion since 2020 and is now more valuable than that of the 9 largest car companies worldwide combined. As a result, car enthusiasts wonder how it is so successful. Even more surprising is how it can achieve 60 miles per hour from zero in just 2 seconds. Watch the video to find out what is inside the Tesla motor and how the car actually works, making it one of the best in the industry. Welcome to the Tesla News Hangout. And today, we are going to explore what's inside the Tesla engine. Tesla was founded on the 1st of July in 2003 by a group of engineers based in San Carlos, California. They launched their first electric car 5 years later in 2008, the Roadster. Since then, they have gone on to design the world's first ever premium all-electric sedan, the Model S, along with many more mind-boggling electric cars that all use the same cutting-edge battery technology Tesla has become so famous for. Unique visual design aside, you may be asking yourself, how exactly do Tesla cars work? Well, if you're looking for a complex explanation, there are some videos that explain the process in a complex way. However, if you would like to gain a deeper understanding of an electric drivetrain without going to school for engineering, you have come to the right place. If you take an iron rod and wrap copper wire around it several times, and then pass electricity through the copper wire, a magnetic field will appear around the iron rod. You will have made an electromagnet. If you take several of these electromagnets and fix them in place in a circle, and then pass electricity through them in an alternating pattern, switching each one on and off again, but with specific timing, and you place a cylindrical and magnetic object in the center. The cylindrical object rotates because when each of the electromagnets turns on it, either pulls on or pushes away the cylindrical object, but the cylindrical object can't move back or forth as it's surrounded by other electromagnets or is otherwise contained. You can imagine that the cylindrical object is similar to a pinwheel, and the magnetic field produced by the electromagnets is similar to the wind you create when blowing on the pinwheel, only there are multiple sources of wind all around this pinwheel. So when you take a break to inhale, one of the other sources of wind can keep blowing and keep the pinwheel turning. In a Tesla motor, the cylindrical object that's being rotated by the electromagnets is also attached to a shaft that runs to the wheels. So when the cylindrical object turns, the wheels also turn. However, the design of the motor is actually a little more complicated. There are other less self-explanatory technical names for the outer shell with the electromagnets and the inner cylinder. So now let's dig deeper into the Tesla car. Tesla cars, such as Model S, have 3 components that contribute to their speed: the motor, the inverter, and the battery pack. Now let's see what are the individual function of these 3 components. Now let's examine what each of these components does. Motor. The first induction motor was invented around 100 years ago by Nikola Tesla. Despite the lack of brushes or a permanent magnet, an induction motor remains extremely powerful. There are 2 main components, the stator and the rotor. The rotor is simply a collection of conducting bars short-circuited by end rings. A 3-phase AC power output is given to the stator. A magnetic field is created by the 3-phase AC in the coils. Tesla motors generate a 4-pole electromagnetic field. Consequently, a current is induced on the rotor bars to make them turn. The most fantastic thing about induction motors is that the rotation speed is determined by the frequency of the AC power supply. This means that the speed of the wheel can be changed by simply varying the frequency of the power supply. Due to this, Teslas have easy and reliable speed control. The speed of a Tesla motor can range from 0 to 18,000 RPM. But where is the motor powered from? It's from a battery pack. Battery pack. Many people will be surprised to learn that the battery packs contain large amounts of common lithium-ion batteries, similar to the ones you use daily. The electric car is powered by a combination of series and parallel interconnections of these cells. Throughout the small gaps between the cells, glycol coolant is passed through metallic tubes. These are some of the things that separate Tesla from other electric car manufacturers. Small cells are used instead of a few large ones to provide essential cooling. As a result, Thermal hotspots are reduced, leading to even cell temperatures, resulting in longer battery life. The cells are arranged in detachable modules, resulting in 16 modules of around 7,000 cells each. Inverter. The battery pack is what supplies the induction motor with power. However, it produces DC power. This means that before the supply can get to the motor, it has to be converted from DC to AC power. This is where the inverter comes into play. Not only does the inverter convert DC to AC, but it also controls the AC power frequency, thus controlling the motor speed. The inverter can even shift the amplitude of the AC motor, which in turn controls the motor output power. Essentially, the inverter acts as the brain of the electric car. And this is how Tesla cars dominate the roads. Then, just when you think you have seen enough, the Musk surprises you yet again. As of earlier this year, Elon Musk has revealed details about Tesla's new electric motor, the plaid carbon-wrapped motor. They are small enough to be picked up by one person, but are capable of achieving insane RPM. During his presentation, Musk briefly mentioned that Tesla had developed a machine to be able to build this new motor. In addition, the CEO elaborated on the machine by stating, "Fiber is wound over rotor at high-tension load. The machine to do this was made by Tesla Automation. Carbon sleeves must put the copper rotor in compression or it loosens at low temperatures due to differential thermal expansion. Preload is also helpful for maintaining the precise gap to the stator." Musk also elaborated on the benefits of the new motor over its predecessors. Main advantage of this is a much stronger EM field compared with a rotor that is held together by metal, usually high-strength steel. Another advantage is that rotor can go to higher RPM, as carbon sleeve, mostly, stops copper rotor from expanding due to radial acceleration. In short, the new carbon-wrapped rotor enables Tesla to push its new motors to a higher level of performance. In the same tweet series, Musk proclaimed that Tesla's new motor is arguably the most advanced motor on Earth. However, he teased that Tesla is working on something even more powerful for the new roadster. The plaid carbon-wrapped motor is arguably the most advanced motor on Earth, outside of maybe a lab somewhere. We have to keep some secrets. We have a few ideas for increasing torque and max RPM even further for the new roadster. Musk may or may not reach his expectations with his new motor, but we hope you enjoyed the video. Please leave your answers in the comments section below. Do not forget to subscribe to our channel Tesla News Hangout, where we talk about Tesla and electric vehicles. While you're at it, hit the bell so you never miss any of our videos, as more exciting ones like this are on the way. In the next one, I'll see you.